Alright, for these on the back, I'm going to slow down a little bit, and I want to actually show you some of the calculator calculations as we go along. I don't really have any particular preference for which ones, but let's start with this one. We'll start with number 13. I'm going to circle that it's either inside or outside. This is an outside. And so that means it is part times full, is what we talked about in the last video. So here's the part, and then what I need is the whole. I need this whole thing. Well, this whole thing is 36 plus x. I saw a lot of people write 36x or something like that. It's not, you know, if this x was 10, well then this whole thing would be 46, not 360, right? So if you're thinking that through, we're just adding those two pieces together to get that. So if I go with my same procedure from the last video, I write the number I circled, and then I have a big square root. In the square root, I use the part that it's close to times the whole thing. And so then my procedure, just like in the last video, is to square both sides. And that the whole idea of that is to try to get rid of this, because we don't want that in our problem anymore. So that's going to give me, on this side, this is 3,600. Here, I don't want this to look all confusing. I'll take some of this off. This is 3,600. Is equal to, and then I'll just grab this guy, 36 times 36 is 1296. So that's, this is 1296 plus this is 36x. I'm just distributing that 36. So then I can subtract 1296 for both sides. And we can do 3600 minus 1296. And we've got 2304. So now this is 2304. We're going to try color. Is equal to 36x. And then I want to divide both sides by 36. So 2204 divided by 6 is 64. So we'll get x equals 64, which I probably should have written in green to keep it consistent, but that's the idea. Moving on to this one, you can see when you're looking for this space, because 48 is an inside one. That means it wants to use both parts. Well, if the whole thing is x, and then this part's 64, well then this part that's left over has to be x minus 64. So that's what you're going to use for this part right here. I should put that together. Let me do one more of the more complicated ones. Maybe we'll do number 17, and I'll leave 18 for you guys. In this one, again, what is it? Inside or outside? It's outside. Outside is part times whole. The part is 75, and the whole, this whole thing, is x plus 75. So when I go through my procedure, whatever I use to determine if it's inside or outside, that's what I write first. And then that's equal to my big square root. In the square root, I've got the part that's next to it times the whole thing. So then if I square both sides, this is one thing I want to show you on the calculator. So I've got 50 radical 3 over there. I can actually put 50 radical 3 in the calculator and square it. Now, that's not that you can't do it in your head. I mean, you could just say, well, 50 radical 3 is 50 squared is 2,500 times the square root of 3 squared is 3 is going to be 7,500. If you want to think it through that way, that's okay too. But I just wanted to show you this was here so that you don't make mistakes trying to do this, just because that's not the point of this chapter. But if we go back here now, I've got 7,500 is equal to 75 times x plus 75. Now this one, in the last problem I distributed this. I just want to show you there's another option. I could, at this point, divide. This is a little more advanced algebraic thinking because it's straying from the normal order we do things in. But you can do that and get rid of this 75. And so over here, if I have 7,500 divided by 75, of course this is 100, is now just equal to x plus 75. And so then if I subtract 75 from both sides, or just ask myself what I add to x to get 100, the answer would be 25.